Today we are going to learn about Ardnt-Eistert reaction. It is very important one. Okay, actually Ardnt-Eistert reaction means which converts the smaller carboxylic acids to the higher carboxylic acid. See here, it is converting smaller carboxylic acids to the higher carboxylic acid. For example, if we take acetic acid, see here, acetic acid is having 2 carbons and where the propanolic acid is having 3 carbons. Means Ardnt-Eistert reaction means very simple concept, with conversion of smaller carboxylic acids to the higher carboxylic acid means which increase in number of carbons. Okay, now we are going to start the Ardnt-Eistert reaction. Actually it is a process of producing higher homolog carboxylic acid using a chain of reactions. Using a chain of reactions means it involves in so many steps. Okay, first see the reaction. Carboxylic acid is reacting with, the first one is SOCl2, which is called as a thionyl chloride. Second one is CH2N2, which is called as diazomethane. Means carboxylic acid is reacting with thionyl chloride followed by reacting with the diazomethane, which results RC double bond OCH-N2, which is called as diazoketone. Okay, diazoketone. This diazoketone further reacts with the water in presence of Ag2O, which releases, again it is also carboxylic acid but which contains 1 carbon excess. See the difference here? Here in between R and C double bond O there is no, see here, in between R and C double bond O there is no CH2 group is available in the reactant, but where in the product one CH2 is added in between R and C double bond O, which means it increases 1 carbon. For this purpose we are reacting with thionyl chloride followed by diazomethane and followed by the reaction with water in presence of Ag2O. For this I took one example, that is acetic acid reacting with thionyl chloride, diazomethane and next one is water. See here, acetic acid contains 2 carbons. After completion of the reaction we are getting propanoic acid which has 3 carbons. Okay, again I am repeating these all things. Ardnt-Eistert reaction, it is a process of producing higher homolog of carboxylic acid using a chain of reaction, simply which converts the lower carboxylic acids to the higher carboxylic acids. Okay, which involves 3 different reactions here. First, carboxylic acid reacts with the thionyl chloride followed by the reaction with diazomethane. Okay, first one thionyl chloride, second one diazomethane, which results diazoketone. This diazoketone further reacts with the water in presence of Ag2O to produce higher carboxylic acids. Okay, for this I took one example, that is acetic acid which has the 2 carbons which reacts with the 3 different reagents, means 3 reactions which converts the propanoic acid which has 3 carbons. Now I am moving for the mechanism. So see the mechanism. First, acetic acid reacts with the thionyl chloride, SOCl2. This is the actual structure of SOCl2. Acetic acid reacts with the thionyl chloride to form acid halide. This acid halide, the second reagent is diazomethane. This is the actual structure of diazomethane. This diazomethane is reacting with acid halide by removing 1 hydrogen from diazomethane and 1 chlorine from here and 1 hydrogen from here, removal of minus HCl, which releases diazoketone. This is the diazoketone. Okay, now this diazoketone is going rearrangement or it removes the nitrogen from here, which removes the nitrogen from diazoketone and which converts in the form of a carbene. This carbene is a less stable one, so only I kept this carbene in the bracket. By shifting of the lone pair which present on the CH towards carbonyl carbonic bond, then which converts in the form of a ketene, means here double lone pair is shifted in between carbonyl carbon and this CH carbon. Then the CH3 is directly attached to the CH carbon. Okay, by this type of rearrangement this carbon is converted as a ketene. Now this ketene is further going to react with the water. Already we finished here two reactions. See here, acetic acid reacted with the first reagent, that is thionyl chloride, which converts acid halide. This acid halide reacts with the diazomethane. This is the second reagent. By reacting with the diazomethane, we are getting the diazoketone. This diazoketone, by removal of the nitrogen N2 from here, we will get a carbene. This carbene is a very less stable one. Now in this carbene, this lone pair is shifted in between carbonyl carbon and CH carbon. At the same time, this CH3 is shifted onto the CH carbon. Due to this rearrangement, this carbene is converted as a ketene. Okay. Now, in the next step, already we used two reagents. One SOCl2 is over and diazomethane is over. Leftover one is the water in presence of silver oxide. That is used in the third last mechanism step. See here the ketene. For understanding purpose, I wrote like this. Same ketene I took here. Now it is reacting with water. Here the OH minus, this OH here is double bond is present in between carbonyl carbon and CH carbon. So here one of the double bond is removed here, hydrogen is added to the carbon and OH is added to the C double bond O group. It is very simple mechanism. It is like a addition type reaction simply. So here removal of a double bond in between carbonyl carbon and CH carbon. Okay, this double bond is removed, hydrogen is added to the CH, OH is added to the carbonyl carbon. This is because of this carbonyl carbon always has the positive character, means this carbonyl carbon is having the positive character. Hence, OH minus is attached on the carbonyl carbon. At the same time, this pi bond shift towards this carbon atom. Then this carbon will get the negative charge. This negative charge attracted by the H plus ion. So, which is converted as a CH2 here, and this OH is attached on carbonyl carbon. Hence, it is converted as a propanoic acid, which has 3 carbons. See here, reactant is having the acetic acid, it is having the 2 carbons. The product propanoic acid is having the 3 carbons. So here using chain of reactions, nothing but reacting with thionyl chloride and reacting with diazomethane, then reacting with water. Okay, this is about Ardnt-Eistert reaction. Okay, thank you.